Hi, everyone. Thank you for attending the session. Kyverno's magic tricks. First we secure, then we automate. I promise this is not a clickbaity title. We are going to talk about few tricks in Kyverno that you can probably derive some inspiration from. I'm Anusha. I'm a product manager at Nirmata. So for those of you who don't know, Nirmata is the creator of Kyverno, and we actively maintain Kyverno in the community. And I manage enterprise offerings at Nirmata, enterprise Kyverno, and other SaaS offerings. And that's it about me. But before we get into this talk, I really want to know how many of you today use Kyverno or even just know about Kyverno? Just a quick show of hands. Oh, quite a lot of people. OK, but still there are a few hands that were not raised. So I'm going to quickly skim through these sections just to set a level playing field. I'm not going to spend too much time. So what exactly is Kyverno? So Kyverno acts as an admission controller in Kubernetes. So if you look at the gray boxes, that is the typical API request lifecycle. So whenever you do something like kubectl create pods or kubectl get pods, the first part is always authentication and authorization, like whether you as a user are allowed to create or list pods or not. Then comes the interesting admission controller bits. There are two types of admission controllers in Kubernetes. One is mutating admission, and the other is validating admission. So mutating admission, as the name suggests, you can literally mutate the incoming request. You can change or modify the request. And after mutating admission is the schema validation, just to ensure you did not mess up with the schema itself. And then comes the validating admission. So this is also pretty powerful. So in Kyverno, you can write a bunch of policies and rules. And if any of these rules evaluate to a false, a Boolean false, then the validating admission controller has the power to reject your request. So if you were listing pods or creating pods, that gets blocked. But if your rules evaluate to true, everything is good, your request gets persisted into HCD. It means whatever you're trying to do is allowed. So Kyverno makes use of these powerful concepts in Kubernetes. Kyverno is a Kubernetes native policy engine. It was born in the cloud native era. It was donated to CNCF back in 2020. And right now, it's an incubating project, already applied for graduation. Hopefully, we graduate soon. And Kyverno is completely Kubernetes native. What do I mean by that? Everything in Kyverno is custom resources and controllers, right? That is one of the most, at least my favorite feature in Kubernetes is it's very easy to extend by the means of custom resources and controllers. So like in Kyverno, all the yellow boxes you see are custom resources. So even the policies and even the reports that are generated are custom resources. So you can do things like kubectl get policies, kubectl get policy reports, and all your familiar tooling that you use for your Kubernetes ecosystem also applies to Kyverno as well. And all the blue boxes there are controllers. So what are controllers? You have a desired state and you have a current state, and it constantly tries to reconcile. So that's what Kyverno does. You have different types of controllers. Like you can, based on your requirement, you can turn on admission controller, you can turn off background controller, and so on. Lots of configurations are possible, but just for an overview point of view, Kyverno is an admission controller. You can have mutating requests, and you can have validating requests. And quickly, these are some of the top use cases. I'm sure if you're using Kyverno, you must be making use of all of these use cases, or at least some of them. The topmost is pod security. And back when pod security policies were deprecated, that's where there was a need for a replacement for it. That's where policy engines like Kyverno and Gatekeeper kind of rose to fame, because you were able to now intercept requests and enforce pod security standards. So all of that is possible with the validate rule in Kyverno. So there are essentially 4 rule types. There's validate, mutate, generate, and verify images. And each of those rule types, they unlock a whole bunch of use cases. From pod security to workload security, things like don't allow latest images in production or in your clusters, right? Always make sure certain tags or SHA is pinned to an image, or make sure there are requests and limits set on your containers, and so on. So all of this you can, again, achieve with validate or mutate rules. Then there's multi-tenancy. So this particular use case is widely popular with mostly OpenShift users, is from what I've seen. So there's a rule type in Kyverno called generate. So with this, you are able to actually generate resources on the fly. Say you have built a platform, and your customer, that is your developer, comes to you and says, hey, I need an environment so that I can deploy my applications. So most probably what will you do? You create a namespace, you create certain roles, role bindings, and make sure they don't do whatever they're not supposed to do. And then you enforce certain, say maybe you enforce network policies, you also have resource quotas and other things. So you kind of build this safe environment for them and then hand it over so that they can continue to deploy applications and other things. So Kyverno makes it very simple to automate all of this. So the only trigger that it needs is something like creation of a namespace. So in Kyverno, everything follows this pattern. There's some trigger that happens. Then you do some set of filtering, you match on certain things, you exclude certain things, and then you do one of these rule types. So always trigger, filter, and execute rule. So in case of multi-tenancy, something like a shared cluster that you have, you create a namespace, you match on certain criteria, and then you execute a bunch of things. In case of generate, you create resource quotas, roles, and so on. And then we have software supply chain security. So there's the fourth rule type, which is verify images. So you can sign your container images using tools like cosign, notary, and a lot of other things. And with Kyverno, you can write policies to actually verify these signatures at the time of deployment, whether there's no man-in-the-middle attack, your container image is the same that had been signed at the time it was built, and so on. And this is a pretty powerful rule, not just images. You can sign attestations. You can attach SBOMs to your image, and you can refer to it at the time of deployment, or even continuous scan as well. So these are the top use cases, and so many talks, blog posts, webinars have been there just to talk about these use cases. And there are about 420 plus policies that are already present in the Kyverno repository. And if you're starting out with Kyverno and if you want to explore one of these use cases, a ready-made policy will already be there. At least it can serve as a template. So do check out our Git repo on that. But today, I don't want to talk about these top use cases because we all know about it, we have used it. I really want to talk about some cool tricks that are there, right? So as a product manager, I talk to a lot of Kyverno users from time to time. I talk to happy users, I talk to grumpy users, and then there are this whole set of creative users. I call them creative, maybe / crazy users, because they really they tell you certain use cases or things that they achieve with Kyverno that even I go like, oh, wow, Kyverno can do that? I didn't know. And that's a very good point for me where maybe, the solution can be built with Kyverno. So there are some very cool, tricks with Kyverno. And those are the ones that I want to share today. So I really wanted it to be like a question-answer format. And I just realized a while ago that I phrased the question as yes or no, and the answer is kind of obvious. But let's just go with it, right? Let's just go with the flow. So question 1, can you use Kyverno to write policies for non-Kubernetes resources? What do you think? Yes, that's what I meant by the obvious answers, but how can you do it? Are you doing it already? OK, so let me tell you. So there's a project called Kyverno JSON. So this was launched last KubeCon in KubeCon Chicago. So with Kyverno, again, it's under the same Kyverno org. So Kyverno JSON, you can apply Kyverno policies to any JSON or YAML payload. OK, so what does that mean? What are the applications of it? So until now, you could write Kyverno policies only for Kubernetes resources. And even back in my diagram, we only spoke about API request lifecycle or admission controllers in Kubernetes. So everything was within the realm of Kubernetes. But what about beyond Kubernetes, right? How can you write policies for that? And until Kyverno JSON, the answer was OPA. Like you could use Open Policy Agent to write Rego policies. But again, Kyverno is well known because you can write policies in YAML, and now you can extend the same Kyverno policies to your non-Kubernetes resources too. And I quickly want to show a small demo for it. Yeah, is this visible? Cool. OK, before I show you the demo, so Kyverno JSON currently is a separate rule engine. So Kyverno is a rule engine, Kyverno JSON is a rule engine. There are plans to unify the two engines because we don't want to maintain two different engines. But that's going to happen at some point. But until then, there are two separate engines. It means they both have different CLIs. So there's a Kyverno CLI. You can do a lot of validate, mutate things with the Kyverno CLI as well. There's a Kyverno JSON CLI now that you can use for JSON resources. So what we have done at Nirmata is we have another, again, CLI, no-brainer, NCTL. This essentially kind of is a wrapper over both CLIs. It's very easy for me to demo with this, so I'm going to use it. Again, the CLI is free to download, but all of the use cases that I mentioned today, you can do it with the Kyverno CLI or Kyverno JSON CLI. So I want to just show this particular command, scan. So now we are going to look at the applications of how you can use Kyverno JSON to scan or to kind of validate non-Kubernetes resources. So here I have scan AWS, scan Dockerfile, Helm, repository, Terraform. So like I said, Kyverno JSON is for any JSON. And a lot of the resources you can express in the form of JSON. So let's just take Dockerfile, for example. I already have a repo that I've created. OK, this also you can see. Great. So I have some Dockerfile best practices. Let's just look at a Dockerfile, right? Like now we can scan a Dockerfile. Now don't confuse this with scanning an image for CVs. This is scanning the raw Dockerfile itself, the instructions written in the Dockerfile. And don't focus on what it is doing, because I just randomly pulled in some instructions there. It might not be working Dockerfile. But the first statement that you see, right? From Python latest. That's already a red flag. And if you were here for capture the flag talk yesterday, I think this was kind of an entry point where latest flag was the base image, and you were able to get lateral access from there. So if you were to scan this Dockerfile at the time it was like merged or deployed or whatever, you could have prevented the attack. Then there's a bunch of things. There's copy statement. Copy is good. Sometimes we don't prefer having add instructions because copy is more predictable. With add instruction, you can probably, if there's a tar file, it will unzip it and then kind of copy it. So copy instructions are good. It's running some pip install. It is having some sudo commands as well, probably not good. It's exposing port 22, maybe it didn't have to, and for some reason it is, and so on. So there are a bunch of instructions. And when there are instructions, they can be good instructions, they can be bad instructions. And you as an org, you might prefer certain best practices. So you might want to enforce certain instructions, right? And that's what we want to do. So I have a bunch of policies here. So let's look at this. Disallow sudo operations. So what is it doing? So this is a Kyverno JSON API. So if you're familiar with Kyverno policies, you must know that you might be using Kyverno API there with a policy or cluster policy as kind. Here you have validating policy. And all of this remains the same. You can add metadata and whatnot. Then in the spec, all you're doing is you're checking whether there are different stages in a Dockerfile. Now, again, going back to what I said, Kyverno JSON, the input has to be a JSON file. You cannot give a raw Dockerfile as an input. So there are, again, open source libraries that you can use to convert a Dockerfile to a JSON representation of it. And this is what it looks like. So it just breaks it down into a Dockerfile into a set of commands. Again, once you have a JSON file, you're good to write a policy. So here you have some commands, and ultimately you have some from image, Python latest, and so on. So you kind of have a tree that you can traverse, and that is very important to, while writing a policy. So once you have this validate base image tag, it is checking from image, this particular hierarchy. If it contains some SHA commit or some version number, then great. And also it checks whether :latest is present. If it is present, then it is false. Once the rule evaluates to false, your policy fails, and you can give that feedback to the developer trying to write the Dockerfile. Let's just look at this in action. So I have Dockerfile best practices. So what I'm going to do is I'm going to scan a Dockerfile. Again, NCTL is just a wrapper over both the CLIs, Kyverno CLI and Kyverno JSON CLI. It just knows when to invoke which engine based on the input resource. So scan Dockerfile. My resource is the Dockerfile. And I have a bunch of policies. And there we go. So yes, so it said found 4 policies. I had 4 policies in there. 3 failed, 1 passed. Let's look at it better. Yes. maybe the formatting is not great, but as you can see, prefer copy over add. It's saying, okay, you're using copy instruction and not add, which is great, so pass. The rest of the things failed, like base image tag failed, pseudo operations failed, and so on. So now, how can this help? Okay, you're running this locally, but what is the real application of it? The power of it is realized when you run this in CI. Because say your developer is trying to update a Docker file and it is violating some of the policies or best practices, you can straight away block their or fail their pipeline and give this feedback earlier to them. So that's why I have something called a shift left folder here. Again, you can have any kind of files, like obviously Kubernetes deployments you can scan. You can also scan Terraform files. How can you scan Terraform files? So you can create Terraform plans, and it is possible to convert these Terraform plans to a JSON format. And once you have a JSON format, you're golden. You can write Kyverno JSON policies. Like here, this is simply creating EC2 instance. It is probably not following any good practices. And I can have policies to check public IP. So whether my EC2 instance has a public IP or not. So when, say, somebody makes a change to the Terraform file itself, and you run these bunch of policies, you can quickly kind of block them while they're writing the policies, as opposed to this is already provisioned in your cloud, and then finally you find out, or some vendor tool is telling you, hey, there's a public IP in your EC2 instance. So how do you do it? In your, for example, this GitHub action, you can, the trigger you can set for whenever a pull request is created for whatever path you want. And you install the CLI, and then you just run the scan. So it just checks in your pull request if there are any offending changes. It will just fail the pipeline, and you're not allowed to merge the code as well. So if shift left is important to you, you should definitely look at scanning all of your configuration files in CI itself. So cool. This was about Kyverno JSON. OK, let's move on. OK, next question. Kyverno is blocking your deployment. How can you fix it? Well, I'm sure you must have faced this. Your developer must have complained that their deployment is being blocked. What are the ways to fix it? Yes, that would be an ideal world. And that should be the long-term goal as well, I agree. Because we're short of time. Any more answers? Perfect. I love you. Yeah, you're great. So that is the most, I think, the practical way and immediate thing that you can do is have policy exceptions, and that's what it was created for. Because some of these, not an answer, because I have heard all of this in either, say, different talks or from different users. So exclude my deployment. Yes, this was true until policy exceptions were introduced, because in Kyverno, like I said, you can have match and exclude blocks. You can go and exclude my favorite deployment, and that policy won't be applied to that deployment. And that's it. Like your deployment won't be blocked. But what are the implications of this? You are going and actually modifying a policy. So that is not a good practice. Not everybody in the company should have RBAC access to updating policies, because you can kind of disable or make it no-op, the policy itself. So that's not a good practice. That's why policy exceptions were introduced, because you don't even have to touch your policy. You install policy exception, and even better, make the policy exception time-bound. You can say the developer, hey, I've given you policy exception for 2 weeks. Fix whatever it is in that timeline. And again, after 2 weeks, I'm going to start blocking your deployment. The other option is run in audit mode. Say your deployment will be blocked only if you're running in enforce mode. And you might say, hey, I'm going to change it to audit mode. But again, that's not a security best practice, because you are now kind of not blocking other deployments too, just because you wanted an exception for your favorite deployment. Deal the policy, like, OK, don't talk to me. But since we're talking about like quirky use cases of Kyverno, you can also use Kyverno's mutate capability to make the incoming resource compliant with your policies. So what does that mean? Say you have a user, they're trying to apply good pod. Kyverno checks it, everything is great, good pod gets persisted into HCD. Now there's another user who's trying to create a bad pod. Kyverno checks it, does not comply, and you kind of reject the request. But what can you do, right? Now this user is grumpy. My deployment is getting blocked. So going back to this concept of ours, mutating admission control always happens before validating admission control. And we can make use of this fact, and this is a very powerful thing. Again, with great power comes great responsibility, so you should be well aware of it. What you can do is you can write a mutating policy that kind of changes, kind of mutates the incoming request and makes it compliant with your validate policy. So your bad pod becomes good pod because of this mutating policy, and everything is good. It can get deployed to your cluster. Again, this comes with a lot of asterisk. Don't start using this as is, because it might not be applicable in your case. Because say, for example, you removed privileged access because of the mutate policy, and your deployment actually needed privileged access to run. Although your deployment will be created, your containers won't start up. It won't run, right? Your developer is still grumpy because their application is not running. So look at the workloads that are running. So this is mostly useful in cases where, say, you have enforced policy to check are all the pods or namespaces labeled correctly. Like, do they have the team label on the pods or deployments? If they're not there, and sure, you can write a mutate policy to add those labels, and you don't really have to block a deployment because a label does not exist. Cool. Next comes, yeah, I have quite some time. Can you use Kyverno for automating compliance controls? How many of you here from the compliance team or have to deal with compliance teams on a regular basis? OK, there are a few of them. So do you currently use Kyverno, or do you think Kyverno can be used for automating compliance controls? Of course, yes. Like I said, the answers are quite obvious. So what you can do is translate compliance controls to Kyverno policies, and you can use the CLI to run offline checks. So compliance controls are fairly generic. Like, let's take an example of CIS, right? So there are CIS controls, and they are it's very broad range. Now you have to interpret what it means for your environment. So there's a whole set of benchmarks for, say, CIS Kubernetes benchmark. So it maps to CIS controls, the generic guideline, and it tells you what it means in a Kubernetes environment. Then each of the cloud providers have their own version of it. There's CIS EKS benchmark, AKS, RKE benchmarks, and so on. So depending upon the type of cluster you're using, you need to be compliant with that version of CIS. So from a broad set of controls, you need to really map to what it means for your environment. And what are some of the compliance controls? Containers should not run in privileged mode. So yes, you must have heard your compliance team say that, or you might get audited for if you're not following this. Yes, you can write a Kyverno policy for it. Another control can be images should not have the latest tag. Again, this particular example is quite overused, but it's also surprising that this is not religiously followed either. Like in sandbox environments, sometimes you just go and say, OK, let me just deploy the latest version of my image. Then clusters should not have publicly accessible endpoint. Then you have to start thinking about what this means for your environment. Does it mean your API server is not accessible, or what exactly it means for your cluster? Then CV report for images should not be older than 2 weeks. Now, this is where things start getting interesting. How do you actually validate this? So you are using vulnerability scanners, maybe like Trivi or Gripe, to give you a CV report for all the images. You can also run these tools on a periodic basis that keep generating, say, on a weekly or bi-weekly basis. They keep generating new reports. If there are any critical ones, they send you an email and so on. But the control says, for all of your images, the report should not be older than 2 weeks. So what do? Maybe a vendor tooling provides this, but how can you do this with Kyverno? It's as simple as writing a policy to do this. So earlier we spoke about verify images rule, and there I mentioned not just the image signature, you can also attest, you can attach attestations. So you can also attach CV reports to your image. What can Kyverno do? It can read your CV report. It can see at what time it was generated, what is the current time, and if there is a difference of 2 weeks, it can flag you. It can tell that, hey, this image in your prod cluster, the report for it is older than 2 weeks. So all you have to do is just write a simple policy and run it in your cluster, and it will notify you whenever you have CV reports older than 2 weeks. The last one, this is my most recent favorite. So every pull request should require 2 approvals. Everybody here, at some point in your lives has created pull requests. And sometimes we are all guilty of, even though you don't have required number of approvals, even if your CI is failing, whatever, you don't have the docs, you go and merge it because whatever the reason, you're not following it, right? But I was talking to a user a couple of weeks ago, and usually they have to do this project assessment that their compliance team requires. It's a bunch of questionnaire, right from audit logs have to be enabled in the EKS cluster to certain Git settings have to be present. So it's a long list of compliance form that they have to fill every quarter and make sure their projects are compliant. And one of the requests was every pull request should require n number of approvals. Now, how do you do it? Now, it's most likely that every quarter, things like this settings won't change. But while filling out a form, you need to make sure that those settings are still true. No, like some user didn't go and change the setting just for their benefit. So this is a very tedious, repetitive, boring task. How do you automate it, right? Like when something gets repetitive and boring, the answer is automation. So how can you use Kyverno for automating this? Again, going back to Kyverno JSON, if you have an input JSON, you can write a policy for this. And how can we do that? I have some example over here. So I have a Git scan. So say all these Git providers, they provide you APIs. So what you can do is you can get all the metadata of a repository. The response is a JSON format. When you have JSON, you're golden. You can write policies. So here I have some examples where check minimum approvals. So I got all the input JSON about my Git repository. And I'm checking the branch protection rules. I'm checking pull request reviews, and what is the minimum count. If it is less than 1, I'm flagging this repository as, hey, this repository is non-compliant. And now it becomes very easy if you are filling out that form, or if you're a compliance person who has to look at 1,000 repositories in your org, you can simply run a tool to tell, hey, give me, it's just single policy. You can just run this CLI and this policy and say, give me all the repositories that are not following this particular rule. You don't need, again, I don't want to kind of name the vendor, but the kind of the Git providers that charge for this kind of compliance tooling is mind-blowing. OK, I have some more time. Cool. OK, this is done. Question 4. Can Kyverno save you money? Can Kyverno make you money? I don't know. I hope so. But what about save you money? Again, the answer is yes. So Kyverno you can use in conjunction with many other projects. So this is, again, one of the cool/crazy use cases that I got to know after talking to one of the users. I've linked the blog, Reducing Cloud Cost of Kubernetes Clusters. So this was written by the platform engineering team of Adidas. So they combined Kyverno and VPA recommendations in order to enforce the recommendations that was generated by VPA. Usually, developers kind of over-provision the resources, and it becomes hard for you to enforce the recommendations, and that's where you can use Kyverno for that. Or if somebody is not following the recommendations, again, Kyverno can help you highlight who is not following those. So Kyverno can be used in conjunction with a lot of these tools. And also another cool use case is with OpenCost. So OpenCost allows you to give you that costing information of every cluster, namespace up to the pod and container level, how much resources it's consuming and what it's costing you. And you can also create budgets. So if you have, say, a $1,000 budget for a dev cluster, and if certain deployment is crossing that threshold, you can either block that deployment using Kyverno, or you can just log it, saying this particular deployment is trying to, overshooting your budget and other things. So you can easily save money, and hopefully money saved is money earned. You can also make money then. You can go read that blog. It's pretty detailed and very cool. The last question. So I kind of, I didn't want it to be all like Kyverno can do this, Kyverno can do that. So is there anything Kyverno can do? OK. I thought there would be a lot of answers. But OK, so this is the time I spent the most on while preparing the slide deck. Like, what do I tell, right? What can't Kyverno do? Like, I mean, I didn't want to name capabilities like Kyverno can't do X, Kyverno can't do Y, Z, and so on, because capabilities at the end of the day can be built. And if I say something is not available today, that might not be true 3 months down the line if somebody hopefully watches my video 3 months down the line, they're like, hey, this person is bullshitting, right? They don't know what they're talking about. This is possible. So I didn't want it to be from a capability perspective. So it should be about how you think of Kyverno as a technology, what it can enable you to do. So Kyverno, at the core, is a rule processing engine. So think of it like, in your platform or in your environment, you want to enforce certain guardrails, or you want to do certain safety checks, or you want to do compliance checks, you want to fill out a checklist, or you just want to enforce good things for your developers. Then I think about 90% of the time, Kyverno will help you do that. The use case might not be straightforward. I'm not saying you'll find it all over the internet. You might have to get a little bit creative, combine it with other tools, and get your job done, basically. So Kyverno can help you do that. Think of it as a rule that you want to write and you want to impose, and Kyverno is there for you. And also, Kyverno is a CNCF project. It integrates very well with other CNCF projects. OpenCost is, I'm not sure if OpenCost is a CNCF project, but again, it's a very good example of how Kyverno integrates with other projects. Kyverno also integrates with something like Crossplane. So the use cases there we come across is, say you don't want to provision EKS cluster in certain region. So if your Crossplane CRDs or compositions are doing that, you can write a Kyverno policy to block such things. So think of it how you can get your job done, the outcomes that you want, and the policies that you can write with Kyverno. Again, with Kyverno JSON, the applications are limitless, because if you had asked me this a year ago, I would say you cannot use Kyverno for non-Kubernetes resources, and that would be the end of discussion. But that's not true today. And Kyverno is also quickly adapting. And like yesterday, there was a talk on validating admission policies and mutating admission policies. So things are evolving in the community as well, and Kyverno is also evolving along with it. You can, obviously, validating admission policies, they run in the API server versus Kyverno, which is a webhook. So Kyverno also supports translating your Kyverno. You can write cell policies. It also converts that to VAPs, and you can harness the power of it. So things change, capabilities are added, things evolve, but your platform needs to be secure, compliant, and safe for your developers to build on. So yeah, I would say think of Kyverno that way. And thanks for joining.
Thank you so much. We still have a little time left, so if there's any questions, raise your hands, and maybe a little light would... Oh, there's one hand there. I can see. Thanks.
Hello. Is there a place where we could find some of these best practice policies, like a repository or something that we could potentially use and modify?
Yep. So there's a Kyverno policies. So go to kyverno.io/policies. So there are a bunch of, a lot of policies, 400 plus policies. So I'd say these act as a good starting point. If you want to talk about like best practices, it's also about how you test your policies. So there's a tool called Chainsaw that's also under the Kyverno org. So that's a way for you to test your policies. Make sure they are robust and reliable in the long run. So you can start with a sample policy here. There are also Chainsaw tests available in the Git repo where all these policies are present. You can also refer to the tests and include that in your development.
Okay, and this includes also Kyverno JSON policies, right?
So like I said, there are different repos right now. So yeah, there are other. So Kyverno for any JSON, and the documentation of it should have some policies. Yeah.
Okay, got it. Thank you.
Yeah.
Maybe one more, if we have time for one more. That's up here.
Thanks for the talk. How do you, is it possible to override the policies temporarily if you need, for example, some privileged pod for just a short amount of time?
Yes, and policy exceptions, like I said, is the way to do that. So what, probably I have 1 minute, I can explain that in 30 seconds. I really like to refer to this diagram. Policy exceptions. So what does this mean? Your policy is in enforce mode. Your user sends a violating resource, or in this case, your pod, which needs a privileged access. you can install policy exception. So policy exception is again first-class resource in Kyverno. A policy exception says this particular policy, this rule, and this resource. For whatever time it is, exclude that particular policy and don't fail that, block that kind of thing. So you can, the right way to do is policy exception, and you can also add a TTL annotation on the policy exception itself so that it can auto-delete itself after a certain time, because policy exception, again, should not be indefinitely there. Thus, they kind of beat the purpose of it. So yeah.
Thank you so much. I think we are out of time. Thank you so much, Anusha. That's a little gift for you there.
Yeah.